Evaluate the limit as x approaches 0 of tangent of 3x over 5x cubed minus 4x. All right, this one is definitely a step up from the other ones. So let's write this out down here. Tangent of 3x over 5x cubed minus 4x. Now, we've got tangent instead of sine here, but we do have a similar issue in that we can't use direct substitution. If we did, the denominator would be equal to 0. It would be an indeterminate form. So we need to do something, and there's a couple of things we might recognize. One, we can rewrite tangent of 3x as sine of 3x over cosine of 3x. We also might recognize that we can factor out an x in the denominator, which might be useful because we're going to need a 3x for our sine of x. So let's go through and do both of those things. We've got the limit as x approaches 0. Let's rewrite that tangent as sine over cosine. So sine of 3x over cosine of 3x. And this is all over x times 5x squared minus 4 when we factor out that x. Now, there's different ways to work with this. What I'm going to do is I'm going to take the denominator and I'm going to rewrite it as a fraction over 1. And so we've got a fraction divided by a fraction, which means that we can just multiply by the reciprocal. So we can rewrite this as the limit as x approaches 0 of sine of 3x over cosine of 3x times the reciprocal of this fraction down here. So that's going to be times 1 over x times 5x squared minus 4. Now, we've got this sine of 3x, and we know we're going to want it to be over 3x so that we can use this trick that we've had before. So what I'm going to do, we've already got an x in the denominator that we can move over there, but we don't have a 3. So I'm going to multiply this whole thing by 3 over 3 to give us the 3 that we want. And I'm going to separate out the sine of 3x over 3x. I'm going to put that in one fraction, and I'm going to put everything else in the other fraction. We're just rearranging things here. So we've got the limit as x approaches 0 of sine of 3x over 3x times whatever's left over after we pull out the sine of 3x and the 3x. In the numerator, when we pull out the sine of 3x, we're left with 1 times 3, which is 3. And then in the denominator, when we pull out the 3 and the x, we're left with the cosine and that other binomial. So we're going to have cosine of 3x times 5x squared minus 4. Now, we can separate this into two different limits, the product of limits. So we can write this as the limit as x approaches 0 of sine of 3x over 3x and times the limit as x approaches 0 of this other limit, this other expression, 3 over cosine of 3x times 5x squared minus 4. Now this first limit, we've done enough of these to know that this is equal to 1 times this second limit. It might look complicated, but we can use direct substitution here. We can plug in 0 for x. 3 times 0 is 0. So we've got cosine of 0 times, if we plug 0 into the x squared, that's going to be 5 times 0 is 0. 0 minus 4 is negative 4. So we've got times negative 4, and then that 3 in the numerator. And cosine of 0 is equal to 1. So 1 times negative 4 is negative 4. So we've got 3 over negative 4 times 1. That is just 3 over negative 4, which we can also write as negative 3/4. And so that whole thing ends up becoming negative 3/4.